Welcome. In this tutorial, I'll be solving question 7. I'll be solving question 7 of this series. That's 9709 October, November, variant 1, paper 3, then for the year 2022. So for those ones who are following, please mark that's the paper that I'm solving. Okay, so I will write the question down. Okay, this is just a classroom. I'll just write on the board, so there's no problem. So we have the equation. Okay, let me indicate this question 7. The equation of a curve. The equation of a curve is y equal to, that is x over the cosine squared of x. For x value in the interval, so we are having x should be either 0 or more than 0, but strictly less than a half pi. So this one you need to switch your calculator in radian modes before we start. And then you have at the point where x equal to a, the tangent to the curve, has a gradient equal to positive 12, has a gradient equal to positive 12. So what do you have to do in this case? Part A, you need to show that A equal to cosine inverse of the cube root so you need to show that it's cosine inverse of the cube root of cos A. That's cos A plus 2a sine A divided by 12. Like that. Okay, guys, what are you supposed to do when you're given this question? That's what you need to investigate together. So I'll write solution. So for this case, they've told you where the x value equal to a, the tangent has a gradient that's equal to 12. So from P1, for us to get the gradient at, okay, this is a gradient, so it's not supposed to be gradient, at any given point, let's say A. What you need to do, you have to differentiate, then you substitute, okay, I'm talking very fast, that's why I'm giving problems here. You have to substitute x equal to a in the result that you'll get after differentiation of the given function. So our function is y equal to x over the square cosine of x. So what do you have to do with this equation? So this equation has been expressed in the form y equal to u over v, whereby u is a function in the numerator and v is also another function in the denominator. Okay, we can also say that it's in the form f of x divided by g of x. So these ones are two functions, but they're taking the parameter values of x. So when you're given these, y prime has to be, you take the first function, you differentiate, multiply by the second function, minus, you differentiate the second function, multiply by the first function, divided by v squared. That is the function in the denominator. So you can start off. Let's mark our u and our v. So our u value is the function in the numerator, which is x. Then our v value, which is the function in the denominator, which is cosine to the power of 2, that is x. Okay, let's start off quickly. So this is what you're having. So it will be x derivative. We differentiate the value of x, we multiply by cosine to the power of 2x minus, that is x, we multiply by the differentiated value of cosine squared of x. Then we divide by, this is a cosine squared of x, and then a squared. So we start off, if we differentiate x, this is a linear function, it's giving us a constant, which is a 1. So this is giving us 1 times the cosine squared of x minus, this is x, multiply by, we need to differentiate this. This one will be, you'll start with the power. You'll start with the power. This one is hiding something here. So we'll start with the power, which is 2. So I can request you write in this form, cosine x and then squared. So we can use chain rule here. Chain rule says that you can start with the power, which is 2 cos x, then we multiply by cos x differentiated. We multiply by cos x differentiated. And this is giving us what? 2 cos x times, this is a negative sine x. Yeah, we get negative sine x, and then, okay. So negative sine x, then multiply by, we pick this argument, we also differentiate it further. So the answer becomes negative 2 cos x sine x. So we're going to have here times negative 2 cos x sine x, like that. Then the answer we divide by, we're going to have this answer we divide by something. That is cosine to the power of 4x. So what are you going to have? This is a cosine to the power of 2x minus, which is plus 2 cos x sine x, then divide by cosine to the power of 4x. So in this case, what you can do, okay, it has been zoomed a bit. Let me just reduce the zooming. So we can factor out something in this equation. We can factor out cos x. Then you can have, in this case, that is cos x. Cos squared x divided by cos x, you get cos x, and then plus cos will disappear, so you're going to have 2 sin x. Divide by, we also factor out, okay, we can just leave the denominator, that's cos to the power of 4x. So cos divides here 1, it divides here cos cubed times of x, like that. So now the answer that we are getting is a dy over dx, or the y prime, is giving us cos x plus 2 sin x divided by cos to the power of 3x. But now in this case, you're told that where the value of x is a, there dy over dx equal to 12. We can substitute in the equation. So let's substitute our dy over dx equal to 12. So we can have 12 equal to cos, where the value of x will replace with a, then plus 2. Okay, I'm sorry, we carried on the wrong value here. So this one is supposed to be 2x. And I will show you why it's supposed to be 2x. So it's 2x because when you are solving up here, remember we had the value x here. Then if you solve for this one here, it's giving us negative 2 cos x sine x. So this is a solution of this part here. So the answer, you need to multiply it further by negative x. That's why you're going to have positive 2x cos x sine x. So we can correct any occurrence that we omitted, any instance that we omitted the value of x. So we can have 2x there, and then this one here, it's already there, but I don't want to assume. Let me just ensure that it's there. So it's 2x here. Then we can start here. This one should be 2a sine a divided by cosine cubed of a. So you can put 1 here, so we can have 1 times the entire of this numerator, which is giving us cos a plus 2a sine a, which equal to 12 cosine cubed of a. So from this one here, we can have cos a as the subject of this equation. We can make cos a the subject of this equation. So what we need to do, we can divide both sides by 12. So divide both sides by 12. So this one cancels out. So you'll have cosine cubed of a equal to cos a plus 2a sine a over 12. Then you can get the cube root on both sides. So we get the cube root on both sides. So this one gives us the value of a. This one gives us the value of a, the value of cos a to be the cube root of. So here we are having cos a plus 2a sine a over 12. And this gives us the value of a as the cosine inverse of the cube root of cos a plus 2a sine a over 12. So this is what you are getting here. And that's how that question is solved. So if you do this, you'll have shown, then you'll be in a position of grabbing all your marks. Thank you. So in the next tutorial, before that, I realized that we have one part left. But in the next tutorial, I'll be solving for the remaining parts of that question. Okay, for now you can take that on as a solution.